Students, in lesson 6.2, our essential question is how can you use models to subtract fractions that have different denominators? So in our last lesson, we worked on adding fractions with unlike denominators, and we used models. Remember, boys and girls, when we had two fractions that had unlike denominators, we had to trade them out. So we will continue on using these methods in our next lesson. So the investigation is going to have us use fraction strips again, and I highly recommend that you use the fraction strips, the virtual ones, which you can get as an app on the iTunes store, and then also the additional website that I provided for you in our last posting about fraction strips. The virtual ones just mean that they're online, they're not physical manipulatives. So we're going to start with the investigation with Mario. Mario fills a hummingbird feeder with 3/4 cups of sugar water on Friday. On Monday, Mario sees that 1/8 cup of sugar water is left. How much sugar water did the hummingbirds drink? So in this activity, we're going to use our fraction strips in our math board. So step A, it says find 3/4 minus 1/8. Place 3 1/4 strips under one whole strip on your math board. Then place a 1/8 strip under the 1/4 strips. So we're going to find the fraction strips all the same denominator. And when we think of same denominator, we should think of like denominators, because that's another way to say same, that fit exactly under the difference. And remember, the word difference means that we're doing subtraction. So we have the 1 red, and then we have 3/4 minus 1/8. So this is a little bit different than what we did in the previous lesson, because so notice this is different than the addition problem because we don't stack the two fractions side by side. We stack the first fraction 3/4 and then the second fraction 1/8 underneath. So the difference is this space in between that's left over. So it says record the difference of 3/4 minus 1/8. So what we do, boys and girls, is remember, we always start with our largest fraction piece, which would be in size our half. Then we move on to our third. Then we move on to our fourth, onto our fifth, and so on. So we think to ourselves, well, we know that we can put eighth pieces under here. So what we're going to do right now is we're going to place the other eighth pieces. So that would be 2/8, 3/8, 4/8, 5/8, 6/8. Now notice, boys and girls, we drew 5/8 in. We're not going to count this original eighth that was there. So when we do 4/8 minus 3/8, we get 5/8. So we know that the hummingbirds drank 5/8 cups of sugar water. Now we're going to go on to the next part, which is draw conclusions. It says, describe how you determine what fraction strips all with the same denominator. Remember, same, another way to say that is we say like denominator, that would fit exactly under the difference. And what are they? So what we say is we try the largest fraction strips first. So remember, boys and girls, the largest fraction strip we have is a half. Then we go on to the third. Then we go on to the fourth. And then we go on to fifth. As the denominator gets larger, the size of the fraction strip gets smaller to see if they fit exactly under the difference. We try the smaller strips until the denominator whose strips fit exactly is found. So we know that the answer is 5 1/5 strips. Oh, I'm sorry about that, boys and girls. I was a little tired when I wrote that. It should be 5 1/8 strips. So the next one, boys and girls, says explain whether you could have used fraction strips with any other denominator to find the difference. If so, what denominator? So boys and girls, we know that no other denominator would work because 1/4 was equivalent to 2/8, and there's no other equivalent fraction relationship from the strips that we have that would prove this relationship to be true, and we would be able to use to solve our problem and find the difference. So boys and girls, we're going to go on to the next step, which is make connections. It says sometimes you can use different sets of the same denominator fraction strips to find the difference. All of the answers will be correct. So what we're going to do is we're going to solve our first problem here, which says 2/3 minus 1/6. Step A says find fraction strips, all the same denominator, that fit exactly under the difference of 2/3 minus 1/6. Now remember, boys and girls, we always have to make sure that we write down 2/3 and then we stack underneath it the next fraction that we're subtracting. So the space that's left over here is what we're trying to figure out what the fits in there. So we know that inside of 1/3 we have 2/6 because we can actually see it if we wanted to draw it in. So we know that we actually have 3/6 that fit inside of the space that's left over, which is our difference or our answer. So now, boys and girls, for B it says find another set of fraction strips, all with the same denominator, that fit exactly under the difference 2/3 minus 1/6. And then it says to draw the fraction strips that we used underneath there. So now, boys and girls, we know that another fraction strip, we always start with our biggest. We start with half, then we move to third, and we move to fourth. If we actually look at this, we know that we could put a fourth and a fourth. So if we have 1/4 and 1/4, we have a total of 2/4. So we know that 2/4 can also fit inside of there. Let's go on to the next step. It says find another fraction strip with all the same denominator that would fit exactly under 2/3 minus 1/6. Draw the fraction strips that we used. So again, we're doing the same problem. And remember, boys and girls, we're just coming up with equivalent fractions. If we look at 3/6, we know that it's not simplified. But if we divide it by 3/3, which is also another way to say 1, we see that the answer is a half. Again, we know that 2/4 is not simplified, but if we divide it by 2/2, which is 1, we would get 1/2. And let's see if we can extend that to the next one. So now, boys and girls, we know that in the next one, we could actually fit our eighths underneath. So we're trying a smaller fraction strip. So we have 4/8, 1/8, 2/8, 3/8, 4/8. So we see, boys and girls, that we have 4/8 that also fit underneath the difference. If we divide that by 4/4, which is 1, we see we get the answer 1/2. So boys and girls, we know that there are several different fractions that could be true to this, but we know that when we simplify them, we have to simplify them and always give our answer in this form, which is 1/2. Now we're going to go on to the next one. So I want to just keep in mind, as you start these next two problems from the share and show, that remember, your first fraction, 7/10, is written there, and then your second fraction, 2/5, is next door, and the difference, the answer, will be what you see there. So very easily, boys and girls, we see that we can fit right underneath there 10th pieces. How many 10th pieces can we fit underneath there? 3/10. Now, boys and girls, we're going to go to the next problem. We see here on the share and show, you have 2/3. For this last problem, we see 2/3, and then we stack 1/4 underneath. The difference is this space that's left over. Remember, when you're trying out fraction strips, always start with the largest pieces and then move to the smaller pieces. As the denominator gets larger, the actual size of the piece gets smaller. So we have 2/3 minus 1/4. So we think to ourselves, will a half fit? No. Will a third fit? No. Will a fourth fit? No. An eighth? No. A seventh? No. Let's try that eighth again. So can we fit an eighth in here? Let's try. 1/8, 2/8, 3/8, 4/8. So we see that we can fit 4/8 in there, so that would be our answer for that one. So remember, boys and girls, when you're doing subtraction of fractions with models, it's different than the addition because you don't stack the two fractions that you're subtracting side by side. You take the first fraction and then you place underneath the second fraction that you're subtracting, and the space that's left over on the right-hand side will be your difference or your answer.